bucka. Haha. You know the deal.
The next thing we're going to talk about in analytic geometry are x and y intercepts. We've talked a fair bit about y-intercepts, so by now hopefully we have a reasonably good idea of what that means. But we're going to explore a little bit more about what a y-intercept is and also talk about x-intercepts. In order to do that, we're going to start with a real-life example. So here I've written an example of a linear relation on the board where the temperature starts at 12 degrees and goes down 2 degrees each hour. So at this point, hopefully we're able to come up with the equation for that pretty quickly. What we're calculating here is what temperature it is. So y is going to represent the temperature. X is going to represent the number of hours. Well, the temperature goes down 2 degrees each hour, so our rate of change here is -2 because it's going down by 2 degrees. We would multiply that times the number of hours, but since we're starting at 12 degrees, our initial value here is +12. So that's what our equation looks like for this example. And so at this point, looking at that equation, we should know a couple of things. The y-intercept is +12, and the slope is -2, or -2 over 1. And what this means for this example is for every 1 hour, the temperature goes down by 2 degrees. So our run is 1, our hour goes up by 1, and our temperature, which is our rise, goes down by 2 degrees. Well, looking at this example again, we know that the y-intercept here represents the temperature that it started at. It was our initial value, which was 12 degrees. But a piece of information that might be useful for this example is, well, when is it going to be 0 degrees? When I'm talking about degrees here, I'm talking about degrees Celsius. So we might want to know when the temperature will get to 0, so we know when the freezing point will happen. Well, y represents our temperature. So we're going to graph this relation and take a look at the graph to explore this a little bit further. So here we have the graph for y equals -2x plus 12. And as we can see here, our y-intercept is 12. So that's our coordinate 0, 12, because on the y-axis, x is always equal to 12. But as I discussed, what's might be a piece of valuable information here is, well, when is it going to get to be 0 degrees? It's 0 degrees when our y value is 0. And our y value is 0 here on the x-axis. And that's the coordinate 6, 0. X is equal to 6 there, but on the x-axis, y is equal to 0. And here, y represents the temperature. So the temperature will get to 0 degrees after 6 hours. And we can confirm that by substituting the value of x for 6 into our equation. So instead of writing x, I'm just writing 6 here. And when we simplify that, -2 times 6 is -12. And -12 plus 12 is 0. So again here, if x is equal to 6, y is equal to 0. So that's our coordinate there. Now this coordinate is where the line touches the x-axis. And that coordinate has a name, and it's called the x-intercept. Just like this coordinate here is called the y-intercept. It's where the line touches the y-axis. And if we look at the y-intercept, we can see on the y-axis, the x value is always equal to 0. So similarly, on the x-axis, the y value is always equal to 0. Because if we're on the x-axis, so if we were here, for example, on the x-axis, well, our value of x there is 20, but our value of y is 0 because we've gone nowhere for y. on our line here, where the line touches the x-axis, is at the coordinate 6, 0. Our value for x is 6, and because we're on the x-axis, our value for y is 0. So for our y-intercept, x always equals 0. For our x-intercept, y will always equal 0. So let's look at another example of an equation of a line, and where we'll find the x and the y-intercepts. So here, the equation is written as y equals mx plus b. So right away, we know what the y-intercept is looking at this equation. We know the y-intercept is positive 15. So our y-intercept is at the coordinate 0, positive 15, or 0, 15. And here we can see why that value always is the y-intercept, because if x is equal to 0, and that's what the x value has to be if we're talking about the y-intercept, well, we're multiplying that number in front of x times 0. So that number with x just disappears. Anything times 0 is just 0. So we confirm that that is the y-intercept by substituting x equal to 0 into the equation. When we do that, 5 times 0 is 0, 0 plus 15 is 15. So that is our y-intercept. Well, unfortunately, we can't look at the equation and know what the x-intercept is. Not when it's written like this, anyway. So the only way to figure out what the x-intercept here is to solve. And what do we know about an x-intercept? Well, we know that the y value has to be equal to 0. So instead of writing y in the equation, I'm going to write 0. And now we have to solve for x. So this is a little bit, it takes a little bit more work than when we had to find the y-intercept, because now I need to actually isolate x. So I'll bring positive 15 over to the other side of the equal sign. It becomes minus 15. Haven't moved 5x, so we'll just leave it there. To get x by itself now, we divide both sides by 5. And we find that our x value is negative 3. So when y equals 0, x equals negative 3. So that's our x-intercept. Because y is equal to 0, that's where the line will touch the x-axis. So as you can see here, when an equation is written as y equals mx plus b, it is convenient to be able to see what the slope and the y-intercept are right away. We know what the y-intercept is, but it's not very convenient if we have to calculate the x-intercept, because we have to do a little bit of moving around to isolate x. So if we have to find intercepts, the slope y-intercept form isn't really the most convenient. I mean, it's convenient to know what the y-intercept is right away, but calculating the x-intercept takes a little bit more work. Let's look at another example where we have to find the x and the y-intercepts, and here's an equation that's written in standard form rather than slope y-intercept form. So we can't look at this equation and know what the y-intercept is right away. So we have to figure out what the y-intercept is, and I'm going to do that one first. And if we're looking for the y-intercept, we know that x has to be equal to 0. So I'm just going to rewrite the equation, but instead of writing x, I'm going to write a 0. Everything else stays exactly the same. Well, now I need to solve y. I'll do as much simplifying as I can. So 5 times 0 is just 0. So we have 2y minus 8 equals 0. Now I'm trying to isolate y, so I'll bring that minus 8 over to the other side. It becomes positive 8. And divide both sides by 2. We find the y-intercept is 4. So if x equals 0, we're finding the y-intercept, and it's at the coordinate 0, 4. So similarly, if we want to find the x-intercept, we're going to make y equal to 0. So I'm just going to rewrite the equation, but instead of writing y, I'm going to write 0, because for the x-intercept, we're on the x-axis, which means our y value is always equal to 0. So again, here we're going to try to solve x, so I do as much simplifying as I can. 2 times 0 is just 0. So all we have now is just 5x and minus 8. Trying to isolate x, so I'll bring that minus 8 over to the other side. It becomes positive 8. And this is a case where it doesn't go in evenly, so my x-intercept is a fraction, 8 over 5. So the coordinate of the x-intercept is 8 over 5, and again, our y value for the x-intercept has to be 0. So to finish off our lesson on x and y intercepts, I'm going to ask you to answer a few questions here. So for each one of these equations, state what the x and the y intercept are for each one. So again, to find the y-intercept, you know x has to be equal to 0. To find the x-intercept, you know y has to be equal to 0. For each of the intercepts, state them as coordinates, as ordered pairs. So give both the x value and the y value for the coordinate. If you're able to do that, congratulations. You now have a firm understanding of how to find the x and y intercepts of a linear equation.